I'm Ryan Osbeck with Copeland Canada, representing Vilter Manufacturing. Let's get into it. Today we're taking apart we're just opening up the one side here for a compressor inspection. It's the HPLD Vilter Single Screw compressor. This is the VSS 222 machine. We're going to pull the side cover off and do a compressor inspection on the gates. Important thing to note initially here, this compressor has already been depressurized and is locked out. Energy's been isolated, so I am safe to proceed. You'll notice some of my previous videos I've said you want to make sure you have that catch tray down below, and I do have a tray, got open oil jug sitting down below to catch any excess oil that's come out of this machine. I have turned this over a couple of times, so I have pushed some oil out. It's had some time to sit actually since before I started this inspection. So some oil has already drained out. So I catch some oil, not a significant amount, which is okay. So as I always like to do, I like to leave the 4 bolts in, top and bottom. I'll back off the bottoms, and then slowly loosen the tops off. And this will help me to control any oil flow. So just in case you don't want to let it just gush right out of there, you want to have some control. This is an O-ring seal, not the gasket seal. We use the O-rings on the high pressure machines. So I'm going to walk those back in a little bit. The plate is stuck on there with the O-ring. With of course being the heat pump, things do bake in. We do want that extra temperature on there. So I'm going to have to try to wiggle here. And it's not going to come freely for me, so I'm going to have to give it a little bit of an influence, a little knock with the back end of my pry bar, just to jar it a little bit. Nothing significant. Didn't need to really hammer on anything. We'll let that oil spill out of there. We'll let that control. There isn't a lot of oil, so it's fortunate this time. This won't take long at all. There, and you can see the oil just pouring out. Collected total only a few cups of oil actually, so there was a significant amount that did get released earlier, which is what I expected. You might have noticed that these are cap screws instead of the standard hex bolts that we use on these machines. The HPLD has a maximum working pressure of 2,000 pounds, 2,000 psi. A standard compressor has 600 psi working pressure. So this is a significantly more heavy-duty casing, and that is why we have those cap screws. It is a heavier bolt. Now you can make this easier on yourself and just use guide rods to pull these head covers off. This is a smaller cover, so I tend to just use my hands. Sometimes you don't necessarily need the impact to work it off. We're open now and inside, so we can get a good look at the compressor. We're going to start looking inside the machine, of course. We're going to do a visual inspection. I'm going to turn it over by hand. We're just going to make sure everything is good right where we need it to be. That's going to do our visual inspection here. We're going to have a good look at everything. We're looking, of course, at the gate rotor edges. We want to look for chipping. We want to see the sealing edges on these faces. These smaller rotors have a little bit less of an identifiable edge on those sealing faces. And we want to make sure that we're examining for damages and wear on every single gate. It is possible that you might only actually have 1 or 2 afflicted gates that you need to check. I've done just about a complete rotation here now. still doing an examination. So you're looking, of course, you're looking for support. You want to make sure everything is clean. You don't have any metal fibers inside, metal particles inside. The gate's doing fine. You want to make sure there's no other issues significantly there. And then once you've kind of done your visual, you can get ready to do your main inspection. So I'm setting up my dial indicator now. It is a bit of a smaller compressor, so it can be a little bit difficult to get your indicators on there. When I travel with minimal tools, and I've traveled out to this site, so I only brought the one indicator with me because that's all I needed for the inspection. I could have brought an assortment of different dials and sizes that would have fit in a little bit easier. I definitely like these hydraulic magnetic bases a little better. Um, I find they're a lot quicker, easier to set up. That works out well. So we're setting up now. I'm going to check for gate rotor. I'm looking for the thrust bearing on these gate rotors. I got a little plastic cap in there to help protect the gates as I push up against it. I'm looking for movement. We're going to do the axial check on the gate rotor thrust bearings. Now, you don't need a lot of force here when you're pushing down on these bars. You can make it say a lot by pushing really hard, and that's really not necessary. And in this particular case, for these bearings, I had a nil measurement reading. So the gates rotor thrust bearings, the axial measurement is okay. The clearance is good. So I'm going to move that base again, and we're going to move on to the next check. And this one should be the bushing float, or the gate rotor float. So we're measuring the float and the bushing between the gate rotor support and the gate rotor itself. So these can be difficult, especially in the smaller machines. You kind of got to watch your back and forth. You want to make sure that the movements are clear. It's not so important that you get 0 on 0 over and over again. What is important is that you get the same reading a number of times. In this case, I actually have 46 thousandths. It feels quite a bit high. It was increased from the last time we did measurements on this machine, but not significant of an increase and still within our tolerances. So I take a little break and pause and every now and then, and I'm actually just writing down the measurements as I go. It is critical that we do write down the measurements. You want to keep good track record of everything as you go. So the next one I'm actually going to do here, this one is our backlash. So this is going to be measured off of the distance between the gate rotor and the actual main rotor. So this is a critical measurement because if you wear out your gate rotors, as your gates wear down, you'll increase your size and you can actually increase bypassing as you lose your oil seal barrier in the compression chamber. Important thing to do is to make sure that the main rotor doesn't turn and that you have your rotor lobes are lined up so that you're perpendicular. You have a finger on the gate rotor perpendicular to the main rotor axis. Backlash on this machine was actually measured quite high at 22 thousandths. Potentially, we're going to be changing out the gate rotors the next time we open this up in a few thousand hours. Remember, this is a test bed compressor, and it is a CO2 high pressure machine. We've run this compressor through the ringer, so measurements on this machine are expected anyways, to be higher than normal. We want to know what these machines are capable of, and we want to know how far we can push their limits. And so far, this machine has actually performed really well over its couple of years of R&D testing. It's held up really good, very minimal issues, and it's run consistently. So, grabbing a set of feeler gauges now, we're going to get the feelers adjusted I'm going to set up the lights. This time we're going to check our shelf clearance. So the shelf clearance is the distance between the gate rotor upper surface and the actual compression shelf. This is a set clearance for wear. For this side, as the thrust bearings wear out, the shelf will actually drop. So it'll get lower, so it'll decrease in size. And on the opposite side, where the thrust bearings are located below the gate rotor on the bottom of the compressor, that shelf clearance will actually increase as they wear out. We're looking for a good measurement between 3 and 4 thousandths of an inch. And this one, as I did test it, I actually came up with a 4 thousandths shelf clearance total reading, which is good. That's exactly where we need it to be, and that's exactly where it should be. So these are 12-inch feeler gauges. Starrett actually makes these ones. There's a few other manufacturers that make these long feeler gauges. For shelf clearances, you can use shim stock if you have it. Smaller feeler gauges. I find for all compressors, these longer 12-inch feeler gauges actually work really well. These ones come in paper sets. You can get them in a large holder set, like smaller feeler gauges, where they come with a little retainer and they kind of screw and unscrew out, so you can take them in and out as you need, or use them all at one big handle if you really wanted. So for this machine, those 4 measurements are bushing float, our thrust bearings, our backlash, and our shelf clearance. Those are the 4 critical inspection measurements on the gate rotor. You'll also need to do on the main rotor an end clearance and an end play or a run out check. And right now I'm currently doing a visual inspection on it. I'm trying to getting a mirror inside there. I'm taking a look at all the main rotor lobes. On these smaller machines, so it is difficult to see a good amount of the road, so you got to get in there, mirror, take a good look around. Again, whenever you open these machines, you're inspecting for metal particles, corrosion, signs of contamination. You want to make sure that there's no bits from gate rotors lying around. You're looking for problems with heat. Make sure you got good lubrication. A really good visual inspection. I would recommend a good quality light while you work. Now with the O-ring seal, you do get that little bits of debris that do build up, so you want to make sure that you wipe, scrape clean any excess surfaces to prevent leaks. If you found that you're getting high spots, some sandcloth or Scotch-Brite pads, clean that off. I was able to do it quite easy and simply with just a rag. With CO2 compressors, actually with all compressors, it is best practice, of course, to replace all elastomers and gaskets, so all O-rings and gaskets. Whenever you remove one, you should be changing it then. I'll be changing one out right now, installing a new O-ring into it. With O-rings, it's nice to lubricate them. You should give them kind of a pre-lube. Clean refrigerant oil is always best. If you're the type of individual that likes to use a light coat of assembly grease to hold things in place, then that's okay too, so long as that grease is compatible with any refrigerants so that you're not contaminating anything. Now I'm going to put this gate rotor cover back on. Studs can be coming real handy here. With these smaller covers, I do tend to just do everything by hand and not typically use the studs to guide things on. You do want to make sure that everything sits flush, especially with the O-ring, because you want to make sure that O-ring didn't pop out. If you pinch that O-ring, it's going to leak, and it's going to start leaking quickly, especially on these CO2 machines. These are high pressure machines. Discharge on this compressor, we actually set at about, I believe it's 1,350 psi is our discharge on this machine. So we're trying to maintain high discharge pressures because we want that high discharge temperature for the heat pump. We're looking to put out as much heat as we can while maintaining safe operation on it. And if you weren't already aware with these HPLDs, our capacity, we don't have slide valves in these machines. So our capacity is actually controlled by VFD drive. So we're VFD driven capacity control, and our volume is fixed port. So per application, our engineers determine what the best volume ratio is for that machine to operate within that, and that gets set as a fixed port. These do have economizers on them, or available for them. Oil injection as well is what we run. So you can, in some of these pipes, you can see the piping that my flashlight's on. There's a tap, that is our oil injection lube line. And then we're going to just button up this machine now. So key to make sure with all these flange cap covers, you want to make sure that you take everything in nice and even. You don't want to have any more pressure off to one side. Metal on metal, like this cover with the O-ring. It's definitely a little harder to get them all cockeyed, so you got one side more closed than the other, but it can still be an issue. So you can way over torque one side compared to the other. So you want to make sure when you draw everything in, you draw it in evenly. I'll take it apart with the impact, and I'll get all the bolts started with that impact driver just because it's nice, quick, and easy, but always finish with a torque wrench. Make sure that you're set accurate, make sure that everything is set accurately and everything is tight and proper. For all your compressors, make sure you consult your manuals for proper torque, and if you can't find it or if you're not sure about it, consult Vilter. We'll gladly tell you what your torque should be for these machines. And it helps if you keep the socket on your torque wrench. I'm just going to finish up torquing here. And then once you're done torquing this side, then you're going to go off to the other side and you're going to torque that one up. Now the other side's a little more adventurous, of course, because the other side has the suction tee on it. So with that suction tee, that's got to come off, and then you can access that gate rotor. So that about covers up our inspection for the gate rotors on an HPLD. Thank you.